Okay, that's perfect. So, hey everyone, my name is Ali. I'm working as a solutions architect in Ververica, and today I want to talk about how we can integrate in different ways Apache Pulsar with Apache Flink, aka make the most out of your Pulsar catalog. So, going back to Ververica, this is the company who initially donated Apache Flink to incubating in 2014. And historically, if you look back at the history of Apache Flink in 2016, it was a version 1. Also, in 2017, Ververica launched its first off-the-shelf product, which was then called the A platform, which was later branded into Ververica platform, where today we have the latest version available. And also, we are the company that is organizing Flink Forward. So if you're interested in anything Flink related, feel free to have a look at it. So what are we going to be speaking about today? So the agenda is, we will start with some background information and continue with some motivation. Why do we want to do this at all? And what are the theory behind it? How can we use the constructs that are provided by Apache Pulsar and Apache Flink, and how actually they are quite familiar when we think about it. So we will also have some small demo, quite similar to what David had, but not that fancy, using stock market, but we will be using Flink SQL. And finally, and hopefully we will be able to have some time for a Q&A. So background information, maybe let me ask you this question. How many of you heard about Apache Flink before? Could you raise your hand, please? Okay, it is maybe half, if not the majority. So Apache Flink, in a nutshell, like today I'm not going to give too much detail of what Apache Flink or Pulsar is, and good that you are already familiar with it, but for the ones that are not, it's a framework and a distributed processing engine for stateful computations over unbounded and bounded data streams. And also, as a background information, Pulsar is also a multi-tenant, high-performance solution for server-to-server messaging, right? There is nothing original here. These are just the texts that I got from their documentation, but I will say it is a good introduction. So for the motivation, we have this system, Apache Pulsar, that is providing many APIs, but also features like multi-tenancy, role-based access control, partition or non-partition tables. And we also have in Flink such features as APIs, which one of them is called Flink SQL, where we have the ANSI compliant SQL, where we can analyze the data. And Flink already has a Pulsar connector, and maybe some features of the Flink SQL is featuring dynamic tables and continuously querying the data and easily transforming any data. So our goal is to be able to use Flink SQL, run Apache Flink applications, and consume the data that is in Pulsar as easily as possible from the application developer's perspective. Okay, so our motivation is actually how to make the most use of the Flink SQL API. So multiple connectors already supported within Flink SQL. Talking about the catalog ecosystem, connectors ecosystem of Apache Flink, recently there have been an initiative to separate the connector repository source code from the main repository of Apache Flink, and Apache Pulsar is already one of the ones that has its own releases under the Flink connector Pulsar repository. Historically, Flink Pulsar connector was maintained by a fork of Apache Flink by Stream Native, and that time they donated the DataStream API connector to Apache Flink. Yet the Flink SQL or Table API connector, as well as the catalog, are still yet to be merged into the official Apache Flink repository. So today, in the theory, let's see what we can used within the Apache Flink APIs. So one of the features of the Flink SQL is the catalog. Catalog is nothing but integration for communicating the metadata with external systems so that you don't need to define all your tables again and again, but you can leverage the already existing information within external systems. This is a screenshot of the Catalog API and what methods it has. In terms of abstraction, the highest level of abstraction in Flink Catalog is the database, right? While defining a catalog, you have multiple databases, right? One catalog could have multiple databases where you can create, drop, alter, and list databases. And within each database, we have several tables, right? We have the table abstraction. So as well as the databases, we can create tables, we can drop them, we can alter them, we can rename them. So one example of a catalog that is already available is JDBC, for example. It is to be able to directly get the tables that are available in a JDBC database. Or the other one is Hive Catalog, which is integrating with Hive Metastore to read the metadata information. So going with the theory of Apache Pulsar, one concept Apache Pulsar has is tenants, right? This is, to my perspective, is one of the unique features that it separates it from different messaging systems. And within each tenant in Apache Pulsar, there could be several namespaces, right? So each tenant can have multiple namespaces, whereas each namespace can have multiple topics, and each topic can have multiple schemas that are versioned. So I hope you are able to see where I am going with this. The previous catalog information, again, to my perspective, corresponds directly with the tenant abstraction within Apache Pulsar, right? And we can consider each database that were in the catalog as a namespace, and we can consider each topic within a namespace as a table directly if we are making the integration with the catalog. And since Apache Pulsar has schema information directly bundled within its ecosystem, aka you don't need additional schema registry to manage your schemas, we can also directly fetch the table information and the schema from the Apache Pulsar itself. So going with some more concepts about Pulsar Catalog. As I said, Pulsar Catalog and the SQL connector for Apache Flink were not yet merged to Apache Flink's connector repository, Apache Flink Pulsar connector, but they were already available within the Stream native Flink distribution, and they already have a catalog logic implemented. And within this catalog, they have two separate concepts. One of them is called native tables, and these native tables are actual topics that are defined in Apache Pulsar, right? And the second concept is explicit tables. So Flink SQL doesn't only have the connector for Apache Pulsar, but you can also have many other connectors. So these explicit tables is, rather than making use of the topic metadata in Pulsar, but to make use of Pulsar as a persistent storage. So using one topic within Pulsar to persist your catalog information in Pulsar itself. So these explicit tables doesn't have to be Pulsar connector, it can be many tables. So within the current Pulsar catalog, that is still not official part of Apache Flink, right? These both native tables and explicit tables concept are handled within a single catalog. So when you take this catalog, when you define a table within this catalog, you have to specify whether this table is a native table or explicit table. And it is actually giving you all the tenants and namespaces not matching with the database and table concepts. So the background information I have given, right? When I think about this, I came up with this read-only Pulsar catalog, where I basically ignore the concept of explicit tables, right? And I want to have one Pulsar catalog that is matching this tenants, namespaces, and topics concept, incorporating with the schema into the catalog in Flink SQL, to the database, to the table, and yeah, basically to the table schema. So in terms of implementation, this is the list databases snippet of the implementation. So here we have a Pulsar admin, and we list the namespaces and get the namespaces for a given tenant, and basically doing some manipulation on the naming, and then returning it. So while defining a catalog, then what we require as an input is also a tenant information. So each catalog now binds to one tenant. And listing the tables is following the same logic, is basically getting the topic list that is part of this tenant and the namespace. Here we are using the database name as the namespace information alongside the tenant information. And the cool stuff here, again, is Pulsar schema, right? Pulsar has different ways to define schema, but to me, so far what made the most sense is to use the JSON schema so far, which expects a overall formatted schema, even though it is JSON. So here then, maybe one example is, this is one Pulsar schema that I previously uploaded to the Pulsar topic. And you see like this schema thing, that is the actual schema. Within schema info is an overall specification valid. Oops. So what this gives me is when I get the table and create the catalog-based table within my catalog implementation, again, what we are seeing here is the implementation of Apache Flink API. And I can already leverage the Auro schema converter of the Flink Table API and generate a schema without writing any custom code, right? So what I define is the schema within the Pulsar itself and automatically using the constructs that are in Apache Flink to get the table schema. The project will be available today, hopefully, on this URL. I mean, we have 3 minutes left, and thank you very much for your attention. But maybe just last thing is like whole point while I was trying to say, my talk is like Flink and Pulsar is a really good, let's say, match. And Flink SQL is probably your best bet when you want to enter this kind of analytics on top of Pulsar. So thank you very much again. And yeah, feel free to check Flink forward.